Okay, one of the first things you need to understand in this redox unit is oxidation numbers. So what are oxidation numbers? Well, sometimes we call them oxidation states and sometimes we call them charges. The official definition is the number of electrons that must be lost or gained to turn an ion into an elemental atom, so make it neutral. Atoms in an elemental form, so atoms that are just elements, always have an oxidation state of 0 because they're already neutral. I don't need to add or gain any electrons to make them neutral. So oxidation states for each of these elements is 0. For Na, for sodium, for O2, for oxygen, for S8, sulfur, for Cl2, for chlorine, for Zn, for zinc, for H2, for hydrogen, for Cu, for copper, for U, for uranium. The oxidation state for all of those and any other element you find on the periodic table. Here's the one thing to remember. See this? Cl2. I'm not going to find this exactly on the periodic table. I'm going to find Cl, but not as a diatomic element. I'm going to find S, but not this. So what you need to remember is that as long as it is one element, so this is 2 chlorines bonded to itself, this is 8 sulfurs bonded to itself. As long as it's the same element, the oxidation state is 0. Okay. Now, if atoms are combined, the oxidation number for each atom will not be 0. So where do we find oxidation states? Right there. So that's the key in your reference table. You're going to find a list of oxidation states. Some elements have positive oxidation states. So what does that mean? That means they have to gain electrons to be neutral because they lost electrons in the first place. Because when you lose an electron, you end up with a positive charge. So the oxidation state says, I'd have to gain electrons to get neutral again. So positive. Some elements have negative oxidation states. That means they would have to lose electrons to be neutral again. Why? Because they gained electrons in the first place to be negative. So some elements have negative oxidation states. Some elements have only one oxidation state, so they just have one listed. Some elements have multiple oxidation states. Nitrogen has a giant list, but lots of other elements have long lists. So what do those positives and negatives mean? Let's look at an example of each. Na plus means it has to gain one electron in order to be neutral again. Why? Because that positive also means it lost one in the first place. So O2, what do you think that means? O2 negative. That means in order to be neutral, what does it have to do? Yep, lose 2. Why? Because it gained 2 in the first place. All right, so remember, when elements are uncombined, the oxidation state is always 0. Like this, Mg, just 0. When elements are combined in a compound, the oxidation states will add up to 0. Okay, here's a compound. Do you see any charges? Nope, 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 you do not. So what does that mean? That means the charge of the overall compound is 0. So the oxidation state or the charge of Na plus the oxidation state or the charge of F added together have to be 0. So let's look them up. Well, there's Na, and there is its oxidation state, and there's F, and there's its oxidation state. So that means if we add them together, we're going to get 0. Let's look at another example. Do you see any charges? No, 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 you should not in a compound. So That means if I take 2 times the oxidation state of K, why do I have to do the 2 times? Because of this. Plus the oxidation state of oxygen will be 0. So find potassium, K, its oxidation state, oxygen, its oxidation state. So 2 times potassium's oxidation state plus oxygen's oxidation state will equal 0. So 2 times a plus 1 is a plus 2. And yes, in fact, when you add them together, you get 0. Some things that might help you. The first element in a compound, it's always going to have a positive oxidation state. If the last element is a nonmetal, it's always going to have a negative oxidation state. Okay, so use the first oxidation state listed on the periodic table in that case. So let's look at an example with that. So MgCl2. Well, I don't see any charges because it's a compound, so that means the charge of the whole thing is negative. So the oxidation state of magnesium plus 2 times the oxidation state of chlorine would be 0. Let's look them up. Okay, well, for chlorine, since chlorine is a nonmetal and it's the last thing in the compound, we're going to use the first oxidation state. So I get plus 2 times the negative 1 equals 0. Add those up. Yep, it is 0. All right, what about for this one? Well, 3 times the oxidation state of lithium plus the oxidation state of phosphorus equals 0. Look up lithium, look up phosphorus. But since phosphorus is a nonmetal and it's the last thing in the formula, use the first oxidation state. So 3 times a plus 1 plus a negative 3. You get plus 3 plus negative 3, which, yes, 0 is 0. Now, sometimes it's not so nice, and there's an oxidation state that you aren't sure about. So you set up an equation. So here, so remember when I wrote it out, the oxidation state of magnesium plus the oxidation state. So let's just write it with symbols. Ready? So magnesium, no subscript, so just 1. Sulfur, no subscript, just 1. Oxygen, a subscript, 4 times oxygen. And since I don't see any charges, because this is a compound, it's going to add up to 0. So let's look them up. Magnesium, sulfur, and oxygen. Okay, we don't know which one for sulfur, so let's find out. Okay, so plug in the ones we do know. We do know magnesium, plus 2, and we do know oxygen, negative 2. Now I'm going to multiply out for the oxygen and get negative 8. I'm going to combine like terms and get negative 6. And now I'm going to add 6 to both sides. And I find out that the oxidation state for sulfur is positive 6. Now notice I didn't just write 6. Positive 6. Okay? Notice on the periodic table, it doesn't just say 6, it says positive 6. So write it like it is. Okay, let's try another one. So let's set up our equation. Well, how many BAs? 1. How many CLs? Well, this 2 gets distributed to everything inside the parentheses. So it should be 1 BA plus 2 CLs plus 2 Os equals 0. Let's look them up. Okay, which is the one I don't know? CL, right? So let's plug in the other stuff. So I get a plus 2 for BA and a negative 2 for oxygen. Multiply out for the oxygen to get negative 4. Combine like terms. I'm going to add 2 to both sides. Now what? Divide by 2, and I'm going to get Cl equals plus 1, right? I'm writing the plus 1. I'm not just writing 1, okay? Now, a little note here, when elements are combined in a polyatomic ion, the oxidation states add up to the charge of the polyatomic ion. So you would set it up exactly the same, but it just wouldn't equal 0. Let me show you what I mean. Here's a polyatomic ion. Let's set up an equation. Well, how many Cl's? 1. How many oxygens? 4. But this time, it's a polyatomic ion. Do you see a charge? Yes, you do. So I do not set it equal to 0. I set it equal to the charge, like this. So let's look them up. I obviously don't know which one for Cl. So let's plug in the oxygen, multiply it out, add 8 to both sides, and I end up with this, plus 7. So the oxidation state for chlorine in this polyatomic ion is plus 7. And of course, there's always a few weird things to remember. So here's hydrogen. The oxidation state of hydrogen is always plus 1, unless it is with a metal. Metals are going to be positive. So hydrogen would be -1. So what do I mean? Like if it was NaH. This would be positive, and this one would have to be negative. Or if it was MgH, that's the only time the H is going to use its negative. Otherwise, it's always going to be positive. And oxygen. It only lists one, -2, which I just think is mean. If it's combined with fluorine. So, but here's how the formula is written. So based on this formula, what do I know? This has to be positive. This has to be negative. So it's going to make oxygen have something that's not here, but that's okay. All right. And in this instance, remember, hydrogen is always what? +1, unless it's with a metal. Well, this is assuredly not a metal. So in this peroxide formula, oxygen is actually going to end up with, as a, since hydrogen was +1, it is going to end up being negative. Couple weird things. All right, what about a Regents example? So here's a whole equation. It says the oxidation number of copper changes from. So I need to find copper. So here's copper right here, and here's copper right here. Well, I know this, that this says it's a solid. There's nothing else here. This is an element. So I know that the oxidation state of copper here is 0. So, and here's the arrow right here, right? So it changed from something to 0. So these two I can eliminate right now. So just remembering that fact got me to a 50-50. Now I have to figure out, is this copper +1 or is this copper +2? Well, here's the formula, CuCl2. Remember, we can reverse the crisscross like this. So the charge for Cu is +2, and the charge for Cl is -1. So it changed, here we go, from +2 to 0. All right, so understanding oxidation numbers is important as we progress and move on in this unit, because we're going to be following where the electrons go. And if you don't understand oxidation numbers, it's going to get harder. So I hope you did learn a little bit about oxidation numbers. That's all we're going to talk about right now. I hope you learned something new.